This is Mrs. O'Neill for AP Chemistry, Chapter 2, Section 5, the periodic table. Another information that's more review, but it's stuff that you do need to know for the AP exam. Your objective is to understand this organization of the periodic table, or a lot of times I abbreviate it as PT. You understand that the elements are put in order according to increasing atomic number, and they are grouped by chemical similarity. So you should have in front of you your blank periodic table along with your packet of notes, maybe some colored pencils or crayons. Even if you don't want to color them in per se, the groups, you might want to write them in different colors just to give you better visual. Use your artistic creativity, do what you want with it. But at the end, you do need to know the major components of the periodic table and the names of the groups on the periodic table. So at this point, you may put whatever you want on your blank periodic table to give you some kind of visual and understanding the components and the parts and the names of the groups. So how many groups and periods are there? Well, there are 7 periods, and we like to say that periods are at the end of the sentence. So a period is a row, where groups are columns, and there's 18 of them. This is an example of a periodic table. There are so many periodic tables out there. The one for your AP exam is very, very basic. It gives you, I believe, the symbol, the atomic number, and the atomic weight. It does not even give you the name, I believe. So be prepared for some quizzes that just do a name and symbol for the elements. But this particular periodic table shows you the metals, the metalloids, and the nonmetals. And notice that your hydrogen is also a nonmetal on the metal side. But there are so many different periodic tables that give you different components. And this is why I made the worksheet for you double-sided. So the one side you could probably put your metals, nonmetals, and metalloids information, and your other side could be more of the group names. So as always, you may want to pause the video, fill in the blanks in your packet, and then play to hear my words. So the major thing you need to know about metals is they lose electrons, and that's going to be really important when we get to redox, as well as when we get to forming ions with those particular elements. Nonmetals gain electrons, and they're involved in the covalent bonds. And metalloids, they have properties of both metals and nonmetals. So depending on their situation, they'll act more like a metal, and you'll name that particular element the ionic way. And sometimes those metalloids act more like nonmetals, and so sometimes they are named more like the covalent way. So it really just depends on their situation. 2 elements you want to keep in mind that are liquid at room temperature. Mercury is a metal, but it is liquid at room temperature. So this mug is holding mercury in it, and it actually can hold this cue ball, number 3. And I thought that was interesting. I mean, you know how heavy those kinds of balls are. So mercury can withstand that. That's how dense it is, but it is liquid. And bromine here also is a liquid at room temperature, and that's a nonmetal. So this is at the point whether you want to fill these in your blank periodic table quickly or just label them, bracket them, whatever your heart desires. But you need to know that this side, the left of that stair-step line that's over here, are considered metals with the exception of hydrogen. So keep that in mind as well. That's going to be the biggest key there. Hydrogen is a nonmetal. So there are your nonmetals. Again, color them in, label them, bracket them, circle them, whatever you need to do. But remember that hydrogen is part of that group. And you have the metalloids, which are right in the middle. And this is aluminum, and this I believe is polonium. Again, those 2 are considered more metals than metalloids, even though they touch that stair-step line. Okay. So again, the parts of the periodic table, there are so many periodic tables out there. This one I thought was neat because it kind of shows you something that the element is in. So I thought that was pretty cool. So the group names, again, at this point, I'm just going to kind of go through this quickly. So if you need to pause the video, again, color in, or you can make dots or swirls or lines or just write in alkali metals. It's up to you. But a lot of times the groups are referred to the elements as names. So then they're not going to say group 1. It might just say an alkali metal. Or it might say something like alkaline earth metal, and you need to know that that element is part of group 2. Then here, groups 3 through 12, they're called the transition metals, and they have certain properties all of their own. Then we're going to skip all the way to group 17 for the halogens. They are going to be very, very important. And the noble gases. Hopefully you remember that those noble gases are important because they do not bond with anybody. However, there are some exceptions to the rules. There are some exceptions where xenon has bonded with fluorine to make a compound. But fluorine is very, very reactive. Fluorine is right here, and that element, he's a high electronegativity. He can get anybody's electrons, even xenon, who's happy the way it is. Then we have what's called the inner transition metals. We want to remember that these are inside. If you don't remember, go back into the beginning of this video where it showed you how those are connected to the transition metals. That's it. Short and sweet.